The scientists didn't drive nearly 300 miles because of Becca Holloway's cattle. They came because of what was happening around them. And the strangest part, it had started with just $47 worth of flower seeds. Becca hadn't expected anything extraordinary. She wasn't conducting a university study. She wasn't testing some expensive new farming technology. She was simply trying something cheap. But a few weeks later, she began noticing something she couldn't explain. The cattle kept returning to one particular section of the pasture. The insects were everywhere, and the ground around the flowers seemed different. Then Becca started keeping notes. That's when a $47 experiment became something much bigger. Rebecca Holloway, everyone called her Becca, was a fourth-generation cattle farmer in eastern Kansas. At 39, she knew her 70 head of beef cattle almost individually. She knew which animals were always first to the gate, which ones preferred the lower part of the pasture, and which sections of grass dried out first during hot weather. She also knew something else. There wasn't much money available for experiments. If she wanted to improve her pasture, she couldn't simply spend thousands of dollars and hope it worked. So she started looking for something inexpensive. No new irrigation system. No expensive machinery. No complicated feed program. Just something she could test on a small piece of land without putting the entire operation at risk. That's when she came across information about flowering plants being incorporated into agricultural systems. The idea caught her attention, not because flowers were pretty, because they could potentially do more than one job. So Becca bought several packets of seed, sunflowers, native wildflowers, a few other flowering varieties. She spent exactly $47. Then she planted them along the north and east edges of one cattle paddock. Her neighbor Dale noticed what she was doing. He leaned against the side of his truck and watched her work. "Cattle don't care whether a pasture is pretty," he said. Becca laughed. She knew he might be right. But $47 wasn't enough to scare her away from finding out, so she planted the seeds. Then she went back to work. At first, nothing happened. The seeds disappeared into the soil. Days passed. Then tiny green shoots appeared. Weeks later, the first flowers began opening. Yellow sunflowers rose above the grass. Small wildflowers appeared beneath them. The cattle continued grazing as if nothing had changed. Becca almost forgot about the experiment. Then one morning she stopped her truck. Something was moving around the flowers. Bees. Not just one or two, dozens. Then she noticed hoverflies, butterflies, beetles, other insects moving between the flowers and surrounding vegetation. The narrow strip of pasture seemed unusually alive. Becca watched for a few minutes before driving on. She didn't think much of it until she noticed the cattle. The herd had begun spending more time near the flower strip. At first, Becca assumed they were looking for shade, but there wasn't enough shade there to explain it. Then she noticed something else. The cattle weren't simply standing there. They would graze nearby, move away, wander across the pasture, and later return to almost the same area again and again. Around the same times of day, Becca became curious. So she started watching. She kept a notebook in the truck. The first page had only a few simple observations. 8:15 a.m. Cattle near flower strip. 10:40 a.m. Most herd moved away. 2:20 p.m. Several returned. Then she added weather, temperature, rain, grazing conditions, insect activity, where the cattle were standing, what the vegetation looked like. She wasn't trying to become a scientist. She simply wanted to know whether she was seeing a real pattern. After 2 weeks, she had enough notes to know one thing: the pattern was real, but she still didn't know what it meant, and that bothered her. So Becca began comparing the flowered section with another part of the pasture. Same cattle, same general soil, similar grass, only one major difference: one section had flowers, the other didn't. That's when she noticed something she hadn't been looking for. The flowered area seemed biologically busier. More insects, more plant variety, more movement close to the ground. And after rain, Becca thought the vegetation around the flower strip seemed to hold moisture differently. She wasn't prepared to call it a scientific result. There were too many variables, so she took pictures. She compared them. She kept writing notes, and eventually she sent several photographs to a county agricultural contact she had worked with years earlier. She expected a simple response. Instead, she received a question. "Have you been measuring what's happening there?" Becca stared at the message. No, she hadn't, not properly. She had observations, photographs, a notebook, and a suspicion. But that question changed how she looked at the entire pasture. Agricultural researchers have increasingly studied farming systems that can perform several functions at once. Instead of thinking of land as simply a place to grow grass or feed cattle, researchers can examine how plants, insects, livestock, soil, and surrounding habitat interact. Flowering cover crops such as sunflower have been studied for their potential to provide resources for pollinators while also contributing forage value for livestock when properly managed. That doesn't mean flowers automatically make cattle healthier. They don't. The results depend on plant species, grazing management, soil, climate, timing, and how the system is managed. But Becca's observation raised an interesting question. Could something as simple as adding flowering plants change the behavior and biological activity of an entire section of pasture? Someone else wanted to find out. A few weeks later, Becca received another message. A researcher wanted to talk. Then another person contacted her. Questions became more specific. How large was the flowered area? When had she planted it? What species were growing there? How often did cattle use that section? What was the weather like? What did the surrounding pasture look like? Becca answered everything she could. She still didn't think it was a big deal. Then she was told that researchers wanted to visit, in person. They would be driving nearly 300 miles. Becca thought there had to be some mistake. For $47 worth of seeds, but several weeks later a vehicle pulled into her farm. Researchers stepped out carrying notebooks, cameras, measuring equipment, and sample containers. Becca walked them toward the pasture, and she found herself saying the same thing she'd been thinking from the beginning. It's only flowers. One of the researchers smiled. That's what makes it interesting. They didn't spend much time admiring the sunflowers. They started looking at everything around them. The researchers examined the flowering plants, then the surrounding vegetation, then the insects. They compared the flowered section with the nearby pasture. They watched where the cattle moved. They looked at the ground. And suddenly, Becca understood why they had driven all that way. They weren't searching for one magical effect. They were looking at the relationships. The flowers provided resources for insects. The insects interacted with the surrounding plants. The flowering plants added diversity to the pasture. And depending on the species and stage of growth, some could also contribute forage. The cattle were part of that system too, not because the flowers somehow transformed them overnight, but because livestock were interacting with a pasture that now contained more than a single type of plant. The researchers weren't looking at a miracle, they were looking at a system, and Becca had created a small one without realizing it. That was the real discovery. Becca hadn't found a secret flower that would revolutionize cattle farming. She hadn't discovered a shortcut that would make every rancher rich. What she had discovered was much more useful. Her pasture could do more than one job at the same time. And she had learned that by spending only $47, the experiment had changed the way she looked at her land. Before, she saw grass. Now she saw relationships, flowers, insects, soil, cattle, weather, grazing patterns. Everything was connected. And the researcher's visit gave her something even more valuable than an answer. It gave her a better question. What else was happening on her farm that she had never stopped to notice? Months earlier, Dale had laughed and told her cattle didn't care whether a pasture was pretty. Maybe he was right. The cattle didn't care about pretty. But the pasture wasn't really about pretty. It was about function. It was about adding another layer to land that was already producing food. And that $47 experiment had taught Becca something she couldn't have learned by buying another piece of equipment. Sometimes the most valuable experiment on a farm isn't the one that costs thousands of dollars. Sometimes it's the one cheap enough to try. Becca hadn't spent $47 to discover a miracle. She had spent $47 to ask a question. And that question was worth a 300-mile drive. Because sometimes the biggest discoveries on a farm don't begin with expensive equipment. They begin when someone notices what everyone else walks past.